Welcome to the Production Livestock Grazing short course. This course has been developed by the UVM Extension Northwest Crops and Soils Program Team with funding from the Vermont Agency of Agriculture, Food, and Markets to provide training for individuals who work with Vermont farmers managing production livestock in pasture systems. The goal of this course is to provide education and resources for new technical service providers with foundational information around grazing planning and providing grazing-related technical assistance to production livestock farmers in Vermont. This course is divided into 5 modules, each covering a different topic area as it relates to providing technical support to grazing operations. You are here. Today we will be covering infrastructure and design for grazing systems. The objective for this module is to understand the physical infrastructure needed for successful grazing systems. Considerations for this infrastructure includes access to resources like shelter, shade, energy, and water, and exclusions from resources such as wetlands and natural resources like streams, ponds, and lakes. The physical infrastructure that we will discuss includes fence systems, laneways, and water systems. We will also review some mapping tools that are useful when designing and planning for infrastructure needs, whether new or improved. Up first, let's consider the basic resources that need to be included and excluded from animal access when working with producers to develop a grazing system that will meet their goals. One of the first aspects to assess when visiting a farm for the purpose of establishing or improving infrastructure is animal access to resources. This, like most infrastructure components, is species and operation specific. The needs of grazing beef cattle, dairy cattle, and small ruminants will all vary. For example, dairy cattle or dairy goats grazing systems may need to be designed around access to the milking facility so that they may return to that facility twice a day. Therefore, all paddocks for the milking herd will need to be within reasonable walking distance. Beef cattle, replacement heifers, or other small ruminants may be moved to further acreage by trailer and not need to be handled for longer periods of time, but may need other handling pens set up for loading and unloading for transport. Additional considerations may be needed to protect small ruminants from predators. Shade by way of access to wooded areas, trees, or other shade structures may be needed depending on the climate and as a way to mitigate heat stress for production animals. Shade access might be less necessary during the cooler spring or fall seasons. Access to electricity may be needed for fence chargers and water pumps. Water is a required nutrient for all production animals. Identifying the best water source and the system needed to allow grazing animals access to it is super important. Systems that require grazing animals to return to the barn for water or do not provide water access for an extended period of time while animals are on pasture will limit animal welfare, growth, and production, and be a barrier to the efficiency of the grazing system. The prioritization of these 4 resources should be understood as they pertain to the farm's grazing goals and individual needs when considering improving existing infrastructure, redesigning and expanding infrastructure, or setting up new infrastructure. Missing one of these resources can break an otherwise well-designed system. For example, if a grazing system is designed to meet organic requirements for dry matter intake, including correctly sized paddocks for the right stocking density of animals, and the right acreage to meet dry matter intake, but it lacks easy access to water, so the producer must truck water to the animals every day, it might not be a sustainable system. Alternatively, if the same system is being utilized, but the acreage without water access is only used as stockpiled feed for extending grazing season at a time of the year when the producer has the time and capacity to truck water daily, this might work. As discussed in Module 1, a main driver for the need for technical assistance providers for grazing systems is to identify and navigate opportunities to improve water quality or mitigate water quality concerns in agricultural settings. assisting producers in their grazing planning and infrastructure design to exclude livestock from waterways such as streams, ponds, and wetlands, and implement practices to protect those waterways in a way that aligns with their grazing and business goals is highly valued. This 2024 report from the Vermont Agency of Agriculture, Food and Markets highlights the year's impacts and farm projects that support preserving and improving water quality. An obvious component of most grazing systems is fence. There are a lot of different types of fence, and once again, the best fit is farm-specific and highly influenced by the type of grazing livestock and the goals and management capacity of the producer. Fence needs for smaller grazing ruminants differ in design from the single or multi-strand wire fence frequently used for cattle. Additionally, pasture that is located remotely or near busy roadways or other high-traffic areas may require a fence with more physical barrier functions, such as woven wire. The best way to learn about the different types of fence is to attend a fence workshop, often facilitated by UVM Extension annually. For the purposes of this module, we will be focusing on electrified wire fence systems. Four components of the electric fence system to consider are the energizer, the grounding system, perimeter fence, and interior fence. Energizers come in all different shapes and sizes. The energizer is responsible for delivering the pulse of electricity to the fence wires. They can be powered through regular plug-in, solar, or even battery. 110-volt powered energizers have the least components and are available in a variety of sizes. Solar-powered energizers are generally less powerful and less efficient than regular energizers and are the most expensive per joule, but may be well suited for smaller areas and are the most portable. Energizers that are battery-powered may work well as long as the batteries are protected from rain and freezing conditions. Batteries may also need to be switched out and recharged frequently, so backup batteries are required. Choosing a well-known brand instead of an off-brand is recommended and money well spent. The power measurement for energizers is the joule. Joules are the power that push the electrical pulse or shock down the fence wire. Stored joules refer to the amount of energy stored inside the energizer's capacitors. Output joules refer to the actual amount of energy delivered to the fence. Energizers should be size based on output joules delivered. 1 output joule per 3 miles of fence wire. In addition to the length of fence to be powered, you also need to consider the number of wire strands that are being powered. Your best bet is to oversize the energizer for the system. A number of tools exist to help find the right energizer for the fence system. While we are not promoting any specific brand, Gallagher has done a nice job providing an energizer selector tool and fence builder tool on their website. You can find the link on the UVM Extension Grazing website under Grazing Infrastructure, Fencing, and Grounding. This link and other helpful resources and tutorials will be linked for this module on the course platform. Grounding is necessary in order for the electrical circuit to be completed between your fence and animal, and thus the electric shock transmitted effectively. Larger capacity energizers will require more grounding rods. Galvanized steel rods should be used and placed at least 10 feet apart and as great as 50 to 100 feet apart, depending on the soil conductivity. The grounding field should be at least 40 feet away from any building or utility power supply. As a general rule, a good grounding system will have 3 to 6 feet of ground rod for every joule and should be connected by 12.5 gauge wire and galvanized clamps. There's a lot going on in this graphic from Wells-Croft Fence Systems. As a service provider, it's super helpful to have a good understanding of the energizer's sizing needs and good grounding. All of the expensive fence posts, wire, and work to install them can be for naught if they aren't properly powered and grounded. Undersized energizers and inefficient grounding systems are a common barrier to well-charged electric fence on livestock farms in Vermont. Idea to take precautions against lightning strike, especially if the fence system is in a high-risk location for lightning strike. If lightning strikes an electric fence system, it can damage or destroy the fence charger. Since electricity follows the path of least resistance from the sky to the ground, lightning will seek objects that can serve as conductors, such as fences. Metal wire makes an excellent conduit. Lightning does not have to strike the fence system directly to cause damage, but can induce voltage on the fence line when lightning strikes several miles away. Energy from the induced lightning will travel along the fence towards the grounding system, which is often on the other side of the energizer. When the energy travels through the energizer to get to the ground rods, the energizer will likely be destroyed. Installing a lightning diverter and choke reduces the threat of lightning damage to an energizer. The coil acts as electromagnetic choke to force the lightning to jump a gap and flow to the ground. For larger areas, lightning diverters can also be located around the perimeter of the fence as added attractants in the event of a lightning strike. Lightning energy can also get to the energizer through the utility line and the power outlet that the energizer is plugged into. Surge protectors are designed to help protect the energizer from electrical surges coming from the main power source. They need to be plugged into a grounded outlet. The one pictured here has a built-in LED that tells that it is properly grounded and functional. Check out the supplemental resources section of this course for instructional videos about lightning protection for electrical fence systems. Perimeter fence is generally permanent fence that is installed around the outside of larger pastures. Once again, the considerations for the materials and installation needs for perimeter fencing is highly dependent on the grazing species. Larger ruminants may be just fine with a 2 or 3 wire system, whereas smaller ruminants may need a woven wire or multi-strand design. Other things to consider are how close to roads, residential, or commercial areas the pasture is, and if there is wildlife pressure from either predators or just from deer or moose that might wreck a weaker perimeter fence. High tensile fence is commonly used for perimeter fence because it utilizes wire that is designed to withstand significant amounts of tension and pressure, is durable, and can be electrified. It can be expensive and requires experienced installation for long-term success. Producers may choose to install their own perimeter fence or hire it out to a contractor. There are many different methods for subdividing larger pastures into correctly sized paddocks for rotation. These interior fences may be permanent or they may be temporary and easily movable depending on how the producer wants to manage the grazing rotation. Portable interior fence options offer flexibility so that the producer may change the paddock size to adapt to the growing season or changing animal numbers. For example, the grazing herd size for a flock of sheep will vary throughout the lambing season and beyond. Using temporary interior fencing materials that can be removed also allows the entire pasture to be easily harvested for stored feed if needed. All fence, both interior subdividing fence and permanent perimeter fence, needs some level of maintenance throughout the season. So it's important to have a good understanding of all of the options and help to match the materials and system that best fit the grazing goals and management capacity of the producer. There are a number of different designs and styles for temporary and movable fence posts. Shown here are pigtail posts, fiberglass posts, ring top posts, and heavy-duty step-in posts. They vary in cost and there is no right post. The best post is the one that fits the producer's preference. Many grazers end up with a variety of different styles. Wire reels can be helpful when moving temporary fence between paddocks that are not the same size because they allow flexibility of wire length. Geared reels are more expensive, but may make for easier and faster fence moving. Choosing a more expensive but more durable temporary wire with more metal strands than the less expensive options will help to maintain good electrical current and last longer. Fence handles come in a variety of shapes and styles. Heavy-duty gate handles are great for gates. Non-conductive gate handles are helpful for saving steps when moving paddock division wires. An invaluable tool to help troubleshoot fence problems is a fault finder. This can help to find shorts or spots in the fence that are either weakening or halting the charge from completing the circuit, and therefore preventing the fence from staying hot. Weaknesses in the fence can result in livestock challenging the fence and possibly escaping, leading to animal safety issues, especially if located near a road or residential areas, and lots of headaches. Check out the video linked in the resources for this module on using a fault finder for more details. If you are interested in learning about all the fence supplies and equipment, attending an in-person fence building workshop, often facilitated annually by UVM Extension, is well worth the time. On to laneways. Laneways provide a well-constructed path for animals to get from one pasture to the next, and to and from shelter or facilities. They also prevent animals from walking through and damaging valuable feed. Laneways can also be designed to accommodate farm equipment like ATVs or tractors and haying equipment. Laneway installation requires some labor, equipment, and materials, including fabric, drainage stone, and a top layer of finer gravel. First, an excavator or similar equipment must be used to prepare the laneway site. Next, road fabric should be laid down under a 10 to 12 inch layer of base stone. On top of the base stone, a 4 to 6 inch layer of fine surface stone should be laid to provide good footing and a smooth surface for animal traffic. There are a few things to think about when planning for a new laneway construction. A great approach is to use a combination of a mapping tool, more information about this coming right up, and actually walking the fields. Working with a producer to take into account both exterior fence and subdividing fences, as well as how animals will most naturally and conveniently utilize the laneways, will determine the details. Avoid wet areas and steep slopes unless there is a plan to address those areas with additional infrastructure. Making gates to paddocks along the lane the same width as the alley will make for a more user-friendly experience. If you are working with a producer to plan for a new grazing infrastructure installment, considering water access and planning for livestock water system is of equal importance for production animals. Livestock have different daily requirements for drinking water depending on their species and physiological state. Water intake may also vary throughout the growing season and be dependent on the source of supplemental feed. Setting up a waterline system to accommodate the needs of the grazing group is key for optimal growth and production. Dairy cattle consume 20 to 30 gallons per animal per day. Mature beef cattle will drink 12 to 20 gallons per day, and smaller ruminants, including sheep and goats, will drink 2 to 3 gallons per day. Water tanks should be sized to hold at least 25% of the daily requirements for the grazing group and allow for 5 to 10% of the animals to drink at the same time. Flow rate should accommodate tank refill in 1 hour or less. Working with a producer to plan for a new waterline system or for making improvements on an existing system is very farm specific. Components of a waterline system for livestock include a good water source or multiple water sources, pipeline that is a minimum 1 inch in diameter and 125 psi, heavy-duty pipeline T-connectors, quick connects, and shutoffs, and water tubs with float systems and hoses for moving them around. PSI is pounds per square inch, and it is a measurement for the force with which water is pushed through the pipes or water pressure. A higher PSI rating means that the pipe can withstand greater force exerted by the water moving through the pipe. Things that need to be considered when assessing a waterline system for livestock are the distance from the fields to the water source capacity, the slope at which the water will need to travel, and the water tub placement within the field. The USDA NRCS Livestock Pipeline Pressure Requirement Worksheet, available in the Resources section for this module, can help to determine the required flow rate, pressure requirements, and pressure tank size needed to accommodate differing water system needs. Lactating cows will drink between 30 and 50% of their total daily water intake within an hour or so after milking, which is also a time when water is being used for cleaning milking equipment, causing water flow going to the waterers to decrease. Water flow rates should accommodate heavy use times, as cows should not have to wait for water source to refill. For fields that are located at elevations above the water source, water pumps may be needed. When using water tubs, consider placement within the pasture. Putting a water tub in a low elevation area of a pasture may cause muddy conditions compared to having tubs in a higher spot. Additionally, portable tubs result in less heavy use areas than stationary tubs. Having a backup source or plan for providing water to grazing animals is clutch, especially during dry stretches or drought. For a deep dive into all things livestock waterline system, check out the supplementary module Livestock Waterline Systems with Vermont Agency of Agriculture Water Quality Program Coordinator Phil Wilson. There are a number of different mapping tools that can be super helpful when working with producers, no matter what the end goal is. Whether you're just trying to get a good measurement of acreage, estimate infrastructure needs, or identify larger paddocks and interior fence division placement, using an online mapping platform with drawing and measuring tools can help you get there. Two frequently used and free online mapping tools that are available for technical service providers to use when mapping and planning grazing systems are the Vermont Agency of Natural Resources, or ANR, Atlas, and Google Earth. Supplementary modules for this portion of the course provide a full walkthrough of these mapping platforms and the tools that they offer that might be useful to you. There are some similarities and differences between these, and it can be helpful to become familiar with both. So check out the recorded content and spend some time exploring them. This concludes the main presentation for Module 4. Be sure to access the 3 supplementary modules for this portion of the course. The first is a deep dive into waterline system design with Phil Wilson, Water Quality Program Coordinator for Vermont Agency of Agriculture. Up next is a walkthrough of the Vermont Agency of Natural Resources Atlas mapping tool and drawing tools with UVM Extension grazing specialist Amber Reed. And then Phil is back with a walkthrough of the Google Earth platform and associated tools.